Good morning, everybody. Welcome to the October Badger Dairy Insight webinar. Thank you for joining us. The Badger Dairy Insight webinar series, if you're unfamiliar, is a webinar series hosted by the University of Wisconsin Division of Extension Dairy Team. And it's a monthly series offered on the third Tuesday of each month. And we provide the latest research on dairy-based information regarding animal welfare, breeding, genetic selection, automation, modernization, and nutrition for producers, dairy workers, and managers. And my name is Caitlin Goldsmith. I'm a statewide dairy outreach specialist with UW-Madison Extension, and I'm going to be the host and moderator for our session today. If you're not familiar, today's session is entitled AMS, Ask the Experts, Your Automatic Milking System Questions Answered. And we have three panelists who are going to be joining us today, and they're going to be answering questions regarding automatic milking systems that have been submitted to us by farmers and producers. But you are also encouraged to submit your questions for the panel, and you can do so using the Q&A function at the bottom of the screen. This webinar is also being recorded, and you can find it on our dairy website in about 1 to 2 weeks, and we will also feature it in our monthly dairy e-newsletter. Originally, we had 4 panelists for this discussion. Unfortunately, Dr. Lizzie French with the USDA Forage Research Center is unable to join us due to the current government shutdown. So sad that she can't join us, but we do have 3 other great panelists that are going to be here today. And those are Doug Reinemann, Marcia Endres, and Nesli Akdeniz. They're going to be introducing themselves, so Nesli can get her name right. I'm very sorry. So to start off, what I want our panelists to do today is take a couple minutes, introduce themselves to our audience, and give a background on their work and their work kind of specific to the AMS world. And just to get it started, I'll assign Doug as our first one to talk.
Well, hello, everyone. I've been at the UW for 35 years and running the UW Milking Research Instruction Lab over that period of time. And I've sort of followed automatic milking from its very start. And my interests, my recent interests are really, it really comes down to profitability. It's like, how can robotic milking systems compete economically with the alternatives, primarily being large rotary parlors. So that is my primary interest right at the moment. And then there's just all sorts of really fascinating questions. I'm an engineer by training, so robots are data collection machines. And so I've been having a lot of fun with enormous data sets coming out of robots and, asking some very, questions that have been around for a long time and finally have the data sets to be able to answer some of those questions. So that's my robot thing.
Thank you, Doug. Marcia, would you like to go next?
I'm Marcia Endres with the University of Minnesota. I'm a professor here in the Department of Animal Science and also an extension dairy specialist. We've done our first surveys with robots back in 2010, I think. So I've been involved doing some research with robotic systems for quite some time. We've done surveys, which is kind of learning what the producers, how they work with robots, why they decide to implement robots, and also using data, like Doug just mentioned. I've done some research with my grad students looking at the data we can get from robots and how that is maybe associated with productivity, for example. Also investigating factors that might influence production per cow, production per robot in AMS systems. So we're seeing a change, of course, in the last 10, 15 years, and it's being a technology that has grown, and we felt it was important as a team here that we work on it and learn more about it.
Thank you. And then Nesli.
Hi, good morning. I'm Nesli Akdeniz. I'm an assistant professor and extension specialist in biological systems engineering, UW-Madison. So I do ventilation studies, ventilation design for traditional buildings, also ventilation design for AMS buildings. One of the tools I use is I develop some computational simulations. So if there are different options that we want to test before testing them on the site, before building them and spending our funds, we are able to test them using our simulations, and we are able to say, yes, this is a promising approach, or this approach needs to be improved. So it is my study area, and I am very glad to be here today.
Thank you. So we have a great spread of panelists today, and I wanted to kick off the conversation with kind of a general question that each of you could answer, which is, when it comes to AMS, what is some of the most or the most common question you seem to get, and how do you usually answer that?
I can start out. The most common question is, what does it cost? And my response to that is, I think a good way of expressing the cost is in terms of cost of milk production. So we've got a number of farms now that have both AMS and conventional milking systems. So there's a number of farms that have been, pretty careful economic analysis of one system versus the other. And if you look across those numbers, the AMS milking is currently more expensive. It has a higher cost of production, and that higher cost ranges between maybe, if you're doing really well, about 50 cents a hundredweight more than. And when I say conventional, I really mean a large rotary. It can be as high as $2, depending on how efficiently you're running your robot system. So, that to me is the critical question for the longevity of the box style systems in the marketplace is, can they get the cost of production competitive with, these large rotary operations? And right now it's not quite there yet.
I think over the years, of course, the questions kind of change, Caitlin, but one question I've been getting a lot recently, I think, and not just from farmers, but also consultants, is how much feed can I feed? How much feed do I need to provide in the robot? Can I go without feed? And as we know, some farmers are doing that now on guided flow farms. They are able to train their animals to come through without providing much at all or nothing. A few farms are doing that in the robot. So that works okay for a guided flow farm, not for a free flow traffic farm. I don't know if people are familiar with the difference. The free flow traffic, cows can access any area of the barn at any time. Can go to the robot, can go to feed, bunk, can go to the beds. Versus the guided flow, we have pre-selection gates that will select the animals that need to be milked into a commitment pen, and then the other animals that do not have to be milked yet, they'll go directly to the feed bunk. So in that case, we're already pre-selecting the animals to go into the robot, so it makes it possible to feed less feed in the robot. So I've noticed over the years, like I said, I've been doing research for the last 15 years with robots or so. We've noticed a decrease in the amount of feed that's offered, even, both, I would say primarily in the guided flow, but even the free flow. And the amounts are probably half what they used to be for the guided flow or less. And then also on the free flow side, we've seen a few more farmers doing more than one feed. In the beginning, we had just one feed. Everybody fed one feed. But in recent surveys, we found that about 30+% of the farms were feeding more than one feed. So you can have a cheaper feed that for all your cows and a more expensive feed for your high producing cows or your fresh cows, things like that. So it's been an evolution in terms of what we feed in the robot. And we also learned very clearly that we need to focus on that partial mix ration and make it that really good and have very good forage quality. So cows come to the feed bunk to eat, and then they go at the robot. So the questions about feeding I get quite often too. I think maybe a little bit with my background in nutrition. So anyway, as an example, there's all kinds of questions out there, but that's an example.
I think from my standpoint, the most common question, yes, one is cost, the other one is fee. They are the most common ones. And then another question is, where do we put these robots inside the building? And unfortunately, we don't have a formula. I don't think we have figured it out yet. We have developed some suggestions, recommendations, but it really depends. Just like anything else in life, right? The answer is it depends. So if it's a brand new farm barn, I mean building, then there are more options. If it's a retrofitted building, then our options are kind of limited. We put them where we can put them. And then what are the measures we need to take to make it work? Then we dive into those questions. Yeah.
Perfect. And I think all three of you kind of gave a good intro to further questions that we had people bring in, including cost and feed and design. I think one of them that I want to start with is a little bit more general, but it is related to cost. We kind of hear farmers bring up afterwards, oh, I didn't know this was going to cost something, or there was this hidden cost I didn't know about. When we're thinking about robots, in your experience, what are some of those costs or considerations that people don't always think about when they're putting in robots or when they're, doing their budgets for the year when it comes to their robots?
Well, there's very high initial costs, right, Caitlin, of the robots. What we don't think about is all the cost of repairs and maintenance and everything that goes with it. So you talk with sometimes the companies might tell it's 10,000 per robot per year, but in reality it might be 20,000, right? So we need to be prepared for the cost of keeping them working properly, because if you don't put that effort and the cost that takes to make it happen, you're not gonna have robots anymore, because they do require a lot of maintenance. And again, there's a cost, and like Doug said, cost of robots is not just the initial, but it's the continuous cost and that it takes to do it.
And just to follow on that, there's a sort of question, does it reduce labor? And you can ask that question a lot of different ways. Is there more people? Are there fewer people? But very clearly, you have a different kind of labor when you're working with robots. So, I hear this concern about the maintenance costs being higher. Well, it's a more complex machine than a conventional milking machine. So it is going to cost more to maintain it, right? And so one of the ways of looking at that is, I can pay someone to to attach milking units all day long, or I can pay someone to maintain my robot. And so there's these kind of trade-offs. And so you have different kind of jobs. You don't have, 12 people that are, you're having to schedule and, have repetitive stress injury and from, work, the process of attaching milking units, but there are other kinds of labor. So I think there's a kind of a false economy when people look at, for example, the maintenance bill. They say, "Oh my God, it's much more expensive." Well, it is more expensive to maintain, and you're paying less for other kinds of labor. So one of the ways I like to look at it is when you're putting in robots, you're creating different kinds of jobs. So you have to look at the kinds of jobs you're creating, and is that sort of dairy farm ecosystem in terms of the jobs and the quality of life and the lifestyle, is that more preferable? That's one of the considerations, and I think to have a more holistic view of the costs, not just to focus on maintenance, because that tends to get people very agitated if their maintenance bill goes up. But it's a trade-off. There's people on the farm you can train to do some of that maintenance work, and you don't. So I think that's one of the I would say sort of misconceptions is that there is a restructuring of the dairy that takes place when you go to robots, and in terms of the types of jobs, the whole cost structure, and then the whole management philosophy is different.
Mhm.
Yeah, I agree with you, Doug, but you still need to be prepared to the fact that it's going to cost a little bit more than you thought initially for these things. At least that's what the farmers tell me. So I talk to every single farmer and they say, they told me it's going to cost me X. In reality, it's cost me a lot more. It's not saying that they're complaining about this, but you need to be prepared because it's a question of economics and being prepared for it and having that available to do so. And I absolutely agree that you train people, and most of the best farms I work with, 80%, 85% more is repairs and all that is done by them, by themselves, by the employees, by themselves to save money, of course. But you still need to have that person or the technician from the supplier, from the company to be around to train the people and also to be able to take care of major problems that might be happening. And if you go into groups and you see how much people are asking about how do I fix this, how do I fix that, for me, like I'm not very handy, so I would be a little bit scared. But getting the right person, like you said, and train that person, you can fix these things. Yes, absolutely. So it kind of replacing different. And most of the farms, the recent survey we did with large dairies across the U.S., I did with UC Davis. Most of the farms are training their own people, the same people. They didn't have to hire new people. They trained their own people they had on the farm to work with robots, right? So it's possible to train them if they're handy and have them fix the robots. So I completely agree with that. So it's a nice way of looking at that it's just like you're replacing the cost, right? You're replacing, so don't get too scared, but be ready to have that money available for the parts and things you need.
Marcia, I actually have a follow-up on that. You mentioned like a lot of farmers, it ends up costing more than maybe what they were told up front. Do you know of maybe a good resource or an idea of what a farmer could expect for a maintenance cost or how they could maybe estimate what that's going to look like?
Most of farmers I work with are telling me around that 20,000, 15 to 25, let's say, $1,000 per robot per year is the cost that they give. And this is the number they give me. That's what they calculated as they start keeping track of it. Of course, that's going to vary a lot related to the age of the robots. Of course, they get older, they have more expensive parts out of warranty. So those kind of things also make a difference, right? So it's hard to come up with just an absolute number, I think. But that's what the farmers tell me. I didn't collect that directly, but that's conversations with the farmers.
Right. Nesli, I think your research is so interesting when it comes to ventilation because it always seems to kind of be something that we think about a little bit about robots, but we're just concerned about getting the robots in, and then ventilation comes later. Is there, do you see a lot of farms afterwards needing to spend that money to fix ventilation that maybe could have been switched up at the beginning? Or just some insights there would be really interesting.
Yes, so one cost is like retrofitting those older facilities, right? If you're going to put those one-way gates, if it is our decision, then, being able to put them and having a barn layout that will work for us, it costs, right? And then as soon as these robots come in, we will need more ventilation fans since they are kind of restriction to airflow, right? And then, okay, we will add more ventilation fans, and then we need to think about that electricity consumption. Like it's not the initial, like we know the initial fan price, right? So we can just calculate that one. That part is easy. But once we put them, then the electricity consumption, how much it will increase our bill. Even we may need a new circuit system. So it may be a very significant cost actually if electricity consumption goes up very significantly, and then having a new system to be able to run those fans, it may make a huge difference. So please keep in mind electricity consumption will go up and then you have the enough infrastructure to support it. So if not, then it needs to be added to the budget.
Makes sense. Kind of continuing on this cost conversation, obviously to all of our attendees, if you have questions, please feel free to throw them in the chat or in the Q&A. But for now, we'll just continue with this cost conversation. We had mentioned it or teased it a little bit earlier of that when you're considering maybe AMS versus upgrading your parlor or putting in a rotary. And Doug, you said you kind of look at that cost per milk production. Is there, some general numbers that you look at that kind of help you when you're thinking about what should I look at if I'm considering doing that? Do you have any suggestions for farmers on numbers that would be good for them to look at?
Well, I think with any kind of major investment like this, you really have to do a good cash flow analysis. I mean, it's a very broad question. It's a very complex question.
Yes.
And so the equity structure of the farm, and it makes a big difference. And And I have not actually seen good economic analysis done, at least published. And I think I don't know, there's financial consulting organizations like Compeer and so forth. I don't know how they approach it, but you certainly need to do a really in-depth financial analysis to figure out if you have the capacity to support the capital expenses that are involved, because they are considerable, right? So, the capital cost per cow can be double what it is for a conventional system. And so, to carry that capital investment, you need to have sufficient cash flow. And like I said, I just haven't seen a good a good financial analysis that's actually been published. I think probably people are doing them, but for some reason we're not seeing them in the literature. I'm sort of basing these sort of back of the envelope numbers on discussions with farms that have both systems. And that's where that 50 cents to $2 a hundredweight difference comes from. Farms that have both systems and are doing sort of a careful analysis. And I'll just say, on this feeding question, one of the selling points of robots early on and still is that you can essentially precision feeding can somehow prove something, right? So what does precision feeding do for us? Well, it might get us more pounds per cow, but really when it comes down to it, the economic advantage of precision feeding really has not materialized. So I don't think you can count precision feeding as a net positive economic factor for robotic milking. And right now, I think it's negative. It costs more in terms of dollars per hundredweight of feed cost if you're doing precision feeding. And there's all kind of reasons for that, but the primary one in my mind is the cows just don't have enough time in the robot to eat enough feed to balance the ration, right? The high producers, you'd want to feed more concentrate in the robot to kind of balance the ration. And there just isn't time, because there's the time pressure to get the cow milked, get the cow in, get the cow out, and there just isn't time to do a really, the type of precision feeding that might be beneficial economically.
Marcia, I'd love to hear your take on that precision feeding with your nutrition background.
Right. So basically, that's, I think, the reason we evolved into focusing a lot more on the PMR, which is a partial mixed ration, right? So that partial mixed ration is what's meeting most of the nutrient requirements for those cows, even the high producing cows. So it's becoming a little more similar, especially in guided flow farms, that TMR, that PMR is almost like a TMR. It's really very similar. And in the robot, they might be feeding a little bit of corn gluten pellets or something like this just to entice the animal to enter the box. But the farm is managed basically like a conventional farm in terms of feeding in those cases. And even the free flow farms are using a little bit less feed in the robot than they used to in the beginning when we started using robots 10, 15, 20 years ago. With no difference in production. So that cost of feeding went down. So that cost of feeding is not maybe as high as you might think. And we do see some benefits. We did a project recently where we fed a different supplement for the first 30 days in milk. Was actually a project. So we had animals in the same pen fed the supplement or not fed the supplement, because we're doing like a controlled study. And we did see 7 pounds more milk for those animals that were fed this particular supplement, which was much better. The cost benefit was about 3-to-1. So basically, cows did produce a lot more milk by feeding this third feed. This farm was already feeding 2 feeds on that dairy. So they had a feed that's a general feed, pelleted feed, and then they were feeding energy supplement to just the high producing cows up to past peak, and then they would stop. And then we added this third one, and I was surprised how much response we got, to be honest. I didn't expect to get that kind of response from the older cows. And of course, the nutritionist that was involved in the study, he's using this in every single robotic dairy he can do that has the ability to feed more than 1 feed because they saw a benefit to it. So it's kind of, there's no broad strike thing that you can say it's not going to work or it's going to work. I think it's a case-by-case situation where in some farms you might see a benefit. But again, the partial mixed ration is what we need to really focus on too. And then economically, that makes a lot of sense to me to get production. I have dairies with guided flow, just using kind of like I said, almost like a TMR, producing over 115 pounds of energy corrected milk average. So yes, you can get very good production, and it's again, each farm is a bit different. So you need to work with your nutritionist. You need to think about what works for your dairy. And again, on the free flow, we do have to feed in the robot. There's no way not to feed in the robot. You have to, but you don't have to feed it maybe as much as we thought initially. So that saves money and also reduces your risk of subclinical ruminal acidosis, because I think we're doing a lot of that in the beginning by like cows eating too much concentrate in there and reducing pH, and fat percent was low. Now fat percentages have gone up. If you look at the fat percentage in robots is a little more normal now compared to conventional. So I think we're learning, Caitlin. It takes time. We're not quite maybe at the end of how to best feed them, but we're a lot better, and cows are healthier, and they are even more productive too. Production per robot has gone up instead of down over the years. So yeah, it's a learning process. We're getting there.
Yeah, you perfectly transitioned into another question that we had, which was related to that kind of acidosis, ketosis in fresh cows. The question is that a real thing? People have talked about that, in robots, when you're feeding, you get higher rates of acidosis or ketosis in fresh cows. Are you seeing that is really actually happening? And if so, what strategies can a farm do to avoid that?
So not as much anymore, based on what I just said. We changed the way we feed them. The project that I mentioned to you earlier, we actually were measuring beta hydroxybutyrate on the cows. We saw no ketosis whatsoever. It was really low. Cows were doing quite well, producing at the time, I think it was 95 or 98 pounds of milk. So high producing herds, well-managed herds that are feeding correctly, we don't see as much of a problem. I think it's just like everything. And you also need to have very good transition cow program. So focus on those pre-fresh cows, make sure they're well fed. They are very comfortable, and they come in ready to go, if you will. So focusing on that pre-fresh stage is also very key in robots, even more than conventional. So they come in really good into the robotic system, and they can, perform well and eat well in the beginning and kind of get that going, so they don't get ketosis, like you're saying. By not feeding too much concentrate, you don't have a lot of subclinical acidosis either. So again, it takes a little learning how to work around that.
Right. And you'd said, I just want to kind of get a little clarification. When you say feeding them well, does that mean providing them with a high quality PMR? Is that kind of the focus?
Yes. So it's a combination. Focus on that PMR, very high quality forage, make sure that's attractive to the animals so they feel like getting up and going eat at the bunk, because hunger is what moves into the robot. It's not what's in the robot. It's not that they feel like, oh my God, I need to be milked because I have a lot of pressure in my udder. No, they don't think that way. They're cows. So they're hungry, they get up, and then they're gonna go through the robot, and they're gonna go to the feed bunk. Both systems, free flow and guided flow, but especially guided flow, what brings them through the robot is being hungry and wanting to go to that feed bunk and eating that PMR. So that's important. And also your feed tables. That's a whole, we can spend a whole hour talking about feed tables and how they feed animals, and do you feed, you feed fixed amounts, and then you move on to by production, pounds, etc. That whole feed table is an art, and that makes a big difference how you set them up. So that's something that takes some effort.
We could do a whole nother webinar on feed tables. If somebody in the audience has a question about feed tables, please feel free to throw them in there and we'll answer them, but we don't want to bog down the whole webinar with feed tables questions. So
exactly.
Kind of moving away a little bit from the nutrition and maybe a little bit more focused on kind of a general question. I think all of you have mentioned that through the years we have seen differences in how we either build robot barns or how we manage robot barns. What are some of the biggest changes that you've kind of seen that you think have been really impactful? This has made a difference switching this up. The thinker.
I think one of the differences, they pay more attention for data use. So before, those ear tags were kind of like part of the deal. We collect this data. Okay, we have the data, right? But they kind of didn't know or didn't have the time how to manage that data, how to use that data. what I see is nowadays they're paying more attention. They are trying to make, use that data. Even there are like farmers, they use those AI tools, right? There are different AI tools. Even they record the weather data and then enter all their information and share with each other whatever they collect using their ear tags. So they're trying to make use of that data more. This is what I see.
Doug or Marcia, got anything to add? Otherwise,
Well, there's so many changes that we've seen
Yeah.
over the years, and it's just like how to like that's more her area. But I mean, how we better design these barns? We need to really improve the cow flow. So how we make it easy? Think like a cow. So make it easy for her to figure out how do I get to this robot and how I move around the barn. One thing, for example, in guided flow farm is the toll booth system. I know I had farmers that just swear by it. Like I didn't have this before. Now it's so much easier. Cows go through, get out. They don't get mixed as they get out. And it's just intuitive. They go in and they can actually figure it out very easily and be trained very easily, right? So the whole design of the barns, I think we learned a lot about. And there's more to learn. Like as you were saying, there's different ways of doing it, but I think that was something I've seen improvement on quite a bit. And also we already discussed feeding, we already discussed maybe the importance of the PMR. And then one thing when the earlier studies we did, we looked at farms that had a automatic feed push-up, like the robots, the feed push-up robots. And we saw 11 pounds more milk on farms that had them compared to farms that did not have them. And at the time, about only 30% of the farms had them. Most recent studies we did, 72% of the farms have them now. So we didn't see much of a difference. But again, having that made a big difference because cows need access to feed at all times in a robot barn, right? So something that I really think is important, not only for robot barns. I wish every farm had one of those. Not trying to sell robot feed pushers, but the robot feed pushers really allow you to have that access. And that really is important for cows, for productivity, right? Because we say, yeah, I push feed, X number of times a day, but not quite enough, I think. So yeah, I've seen a lot more use of that too. The other technologies that go along with robots, if you will.
Well, and I have to say that this is kind of a rather recent thing, and so it remains to be seen how it's going to work out. But Marcia mentioned earlier that several farms have removed all feeding from the robot. And another sort of adaptation of that is batch milking systems, where you have it looks more like a conventional parlor where you have a holding area, you bring a group in, and those batch milking systems typically don't feed. So both of those options are a way of reducing the cost of the robot, the capital cost of the robot. The feeding system adds considerable expense. And so it's again, I haven't seen a good economic analysis of it, but I think it's a strategy that can improve the economics. And again, as Marcia said, we've got TMR herds that are doing 115 pounds a day. So, we know how to feed cows with TMR and get high production. I mean, we've been working on that for 100 years, right? That's a very fine-tuned system. And so, yeah, I think that whole question of feeding is an interesting one, whether or not, we used to feed in conventional parlors, still do in some grazing herds, right? But that's kind of really gone away because, you're kind of there to milk the cows. You're not, you're trying to combine two things, feeding and milking, and there's certain friction points there. So I think it'll be interesting to see how this, whether or not just eliminating the feed in the robot will be a positive step. I don't know. I don't know. We'll see. I'm not willing to to place a bet on that one.
That makes sense. Yeah, it is kind of in the stages of we are finding out. We are still looking at it, seeing how it's going to work, but it's definitely an interesting step that we're moving in.
Only for guided flow, however. Just a
Yeah.
disclaimer here.
Yeah.
Do not think of doing this for free flow because free flow, we do need to have something in the robot to get the cows in there.
Yeah.
So please do not. If you have free flow farm, we're talking about guided flow here, please.
Yeah. Well, and the batch milking systems are the ultimate guided flow, right? So, you bring the cow to the holding area. That's really extreme guided flow if you want to think about it that way.
Right. What would you think of cost of that? You guys look at cost of that. It's just like we need so many of those boxes.
Well,
I've sold on it. I'm not sold on it yet. I've been to
yeah, I
just
think
one of these farms
like
in the US. I was like, I don't know.
yeah, I think it, it has the potential to have better box use efficiency, right? So that just in itself. So there's two things about it that might give it an economic advantage.
Okay.
Uh, Reduced, cost per machine because of not feeding. There might be other cost reductions by going through to a batch system. And then also the just the number of hours per day that the box is actually milking a cow potentially is higher because you've got a more controlled traffic going on in that sit scenario. But we've only got a few farms that have been brave enough
Right.
to try it, and it's still very early and
Yeah, it's
we'll
hard to tell. Yeah.
see how
Yeah.
they go.
Good point. Yeah.
Marcia, you kind of introed this with, you keep introing my questions very well. With the
Okay.
feed pusher, we had a question that was, I think this farmer is probably in the stages of maybe thinking about implementing robots. And the question is, are there other technologies that are smart to implement with robots? So like you mentioned, the feed pusher, are there other technologies that seem to make sense with robots?
Yeah, a lot of our farms will have automatic scrapers, right? So you're trying to disrupt as minimum as possible going in the pen and disturbing the cows. So a lot of those farms, even though I have a love and hate relationship with automatic scrapers, my colleague here, Gerard Kramer, always calls them the tsunami of manure, as it kind of brings that manure out of the barn. So I don't love that part of it, but again, it's less disruption, right? We do have some company, at least one company I work with, that offer basically a vacuum cleaner of sorts, which is a robot vacuum that gets rid of manure. But again, there's a whole additional cost to that and also maintenance of this particular piece of equipment. So I don't see a lot of those, but there's some farms that have that as an option. So again, that's maybe something. I'd say a lot of cow brushes. So cow brushes are not something that has been proven that improves productivity, but it definitely improves cow comfort and cows enjoy it. So a lot of these robotic farms will have brushes, cow brushes. That's very typical. Another technology I see some farms have is having a feeder in the dry pen. So it's an automatic feeder that cows go into a box to eat. So that it's very useful to train heifers, to train animals to be unafraid of going into a box to eat a little bit. So that works especially if you're going to have a free flow system where then cows will have to go into a box and then they know there's a little feed in there, so they'll entice them. So that is a nice training tool. I've seen some farms implementing. So those are some technologies that I commonly see. And of course, as in the ventilation side of things, those smart fans, I really like them. I have a farm that has those smart fans, which cools different areas of the barn appropriately based on temperature, humidity. So again, everything adds up. So all of a sudden, like Doug said, forget it. It's gonna be way too expensive. But if you have those, you're gonna have very good cow comfort. So again, there's different options out there.
Mm-hmm. Yeah, the dream farm sometimes includes things that are not in our budget, but it is the dream farm. Kind of switching a little bit to design. Um, when we are designing robot barns, are there maybe some key features that get overlooked a little bit? I think a common one that maybe comes to mind is where is that foot bath going to be located? Are there other things that come to mind that maybe get overlooked when it comes to design?
So one of the things that sometimes we overlook is not having an air inlet for ventilation fans. So having a supply fans is good. So we recently published a study. Supply fans are good. I cannot say they're not good, but they have very limited benefit, especially if we are thinking about that the airflow at the cow level, their benefit is very limited. So instead of having those supply fans, it's not like the more the better. Let's have many, many fans. Let's put many fans in this barn and then make it work. It's not how it works, right? So having a big opening air inlet, right? And then getting help from Mother Nature a little bit, assuming that wind blows from west or southwest or northwest in winter. Having that help a little bit and then having that natural airflow coming in, it helps a lot. So if you have the supply fans, then you need to match the exhaust fans capacity with the supply fans capacity. As the fans get older and dirtier, it stops matching. And then you're not taking the advantage of those windy days. You're just running those supply fans continuously. Then the, ventilation efficiency goes down significantly. This is what we figured out in our recent study.
Mhm.
Mhm.
Marcia or Doug, do you have any design features that maybe you would urge farmers make sure you remember these?
Yeah, I agree with her. Ventilation is a key one, right? So it's good that we're doing more research on that. Nicely, thank you to figure it out. What's the best and looks in economics of it. And also the placement. You mentioned earlier already, Nesli, the placement of the robot, where it goes, the distance cows have to walk. So that's something we also learn about the design. Is it L shape? Is it toe booth an option or whatever? And there's different ways of doing it. So I'm not saying there's just one way, but those are things that still kind of, I don't know if we know the best option yet. We've been changing over the years. And also one thing that's very important, I think, is to have sort pens. So new builds, we can have a sort pen. So those are cows that get selected out of the robot to be doing something with them. And what producers tell me over and over and over is that I should have them make them bigger. I should have more space here. I should have had more. So I think that's one thing they learned, make them big enough. So that we can, especially as dairies get larger, you need to have enough of those pens and make them make sure there's enough stalls, enough eating spaces and all that. So that's one thing I hear over and over.
Do those farms ever tell you if they were to build them bigger, how big they would like?
They would double. A lot of
Yeah.
times they tell me I would have double. Instead of 20 stalls, I would have 40. If instead of 10, I would have 20 or whatever. Usually they tell me I probably would have double the number of stalls.
Mhm.
Because they use that a lot for management.
Mhm.
Even to train their heifers. So you put them in there in the beginning so they can actually still access the robot, but you have them in a smaller space so you can train them for 40 years, whatever, before they go into the general population. So that really helps with labor. So again, back to labor efficiency, right? So that really helps how you approach the training, for example, having a space for them with that
Yeah.
sort pens, for example.
Those sort pens can be really helpful, yes.
Yeah.
Marcia mentioned it, Nestle mentioned it as well. Placement of robots, especially when it comes to ventilation. Nestle, I read your recent article. Very interesting what came out of that. Could you kind of share maybe what you've learned in that article or just in your other work as well when it comes to that placement and ventilation? Is there a best placement or any ideas on that?
Yes, there is a best placement, but it doesn't work for all farms, right? It really is. So if we have a tunnel, so in that study, what we did, we compared a tunnel ventilated building to a cross ventilated building. And in a tunnel ventilated building, there isn't a lot of options, right? In that building, in that specific design, they put the robots in front of the air inlet, actually in front of the supply fence where the air was coming in. And then they added a lot of circulation fans with the hope that that improves the situation. Circulation fans help, but since the robots were kind of placed perpendicular to the airflow, they block. So our simulations, like this is simulation, right? What we can do is we can do any kind of academic exercise. What we did, we removed the robots and then look at the temperature distribution. We put back the robots and then look at the temperature distribution, and they do affect the temperature distribution. So temperature increases since they are blocking the airflow. The other barn was a cross-ventilated barn, but in a cross-ventilated barn, there's a little bit more space, right? Maybe it's not a fair comparison, but it was a cross-ventilated barn. So they put those robots by the wall, so on the side. So they are kind of parallel to the airflow, but they are not in front of the air inlet. So even if we remove the robots or put them back, temperature distribution didn't change. Yes, there is a formula, but it doesn't apply to all the buildings, right? If it's a tunnel ventilated building, it's a long rectangle building, then there is nothing else we can do. But like whatever we put inside a building, if we are thinking from ventilation standpoint, please make sure it's parallel to the airflow. It doesn't have to be a robot. Whatever we are, even we are putting a hay bale, it needs to be parallel to the airflow so it doesn't block the airflow.
That is.
So based on what you just said, Nesli, you're suggesting maybe that a cross vent would be more appropriate or preferable, if you will, for robot barns?
I'm a little bit afraid to say that in an
Okay,
ideal world we would want cross ventilation, but I do understand it doesn't work like that all the time.
right. But if you could build new, that would be a recommendation, maybe. So I'm asking. Okay,
In
sounds good.
general, cross ventilation works better than
Okay,
tunnel.
yeah, I see more of those than I see tunnel actually, at least here in the Midwest. So which is good. So they're doing it right, hopefully, by doing cross vent.
Mhm.
I-
So, sorry, go ahead, Doug.
well, I would say one of the intriguing questions to me has to do with group size and pen size, number of AMS per pen, and it has grown as experience with AMS has grown, more cows, more AMS per pen. And I think it's an interesting question. There are certain advantages in smaller group size because you can formulate groups that, for management groups that you can do more precision management. On the other hand, the farms typically like to have large group size, and people talking about, 4 or 5 AMS per pen with, 300, 400 cows. And it's like, I think there's an upper limit. And one of the real problems you get into when you get a lot of AMS per pen is the traffic flow. So, it's really hard to get cows in to a whole bunch of robots and get them back out without crossing each other. And it's a very difficult geometric, configuration to make the cow traffic work when you get multiple EMS per pen. So, I think there's clear advantages like 2 AMS per pen seems to work fine. Three, I don't know, I don't know if there's where the advantage point is, but I think the other thing, if you think about creating pens, um, there's also certain advantages from a management perspective on having different size pens. So, I think there's a point of having one pen with 1 AMS. It's going to be a smaller group, right? You got another pen with 2 AMS, and you might have another, pens with 3 or 4. And so I think that makes sense from a management perspective. I don't see people doing it that much. Usually when you go to a barn, they're all the same. The pen size are all the same, and the number of AMS per pen are all the same. But I think there's reason to think about different size pens, and then when you get into these bigger pen sizes, is there really, what's the real advantage in that? Because there's a clear disadvantage at this point in terms of cow traffic when you have, 3, 4 AMS per pen.
And that
Thanks.
kind of led into a question that was asked. Flip it a little bit. So you're talking about AMS per pen. I think I hear more grumblings about how overstocked do we do this pen in terms of cows per laying stall?
Yeah.
Is there any idea? I mean, it's kind of a new concept, people really overstocking these stalls. So do we know anything yet about how it affects efficiency or performance?
I've been amazed at some of the extreme overstocking situations that work extremely well. I mean, I'm really surprised. I would never have recommended overstocking like, 50, 60%, but there are farms that are doing it, and it seems to be working well for them. So I think it's another one of those big questions. I think, it requires a higher level of management intensity in order to be able to do that. So I wouldn't recommend it for everyone, but clearly there are farms that are overstocking the stalls by a considerable amount, and it makes sense because, in a robot barn with voluntary cow traffic, a certain percentage of the cows are always up, right? And you kind of want a certain percentage of the cows up all the time. So it kind of facilitates cow traffic in a way. But I think it takes really careful. You got to really monitor those systems carefully, and
Mhm.
and it there there are some potential problems with it, but
Yeah, I
There are
agree
some
with
farms
Doug.
that
So
manage.
surprising, right, Doug? I have a farmer that's following for me. He has the sensors and he's looking at lameness and he's looking at everything. And I was
Yeah,
like, how is it so far? A year and a
yeah,
half later, whatever.
yeah,
Still good. I was like, ugh. And they put an extra robot. So they actually have an extra robot. They buy an older robot, they put them on their robot.
yes,
So they have more
yeah.
robots. So the robot's only, instead of 60, 70 cows, it's like 50 or less. So there's enough space, enough time for cows to be milked. But I always, as I'm cow comfort is my other area of specialty, I got nervous about what is the long-term implications of these animals not having space, enough space to lie down, enough space to eat. I don't know. I get nervous, Doug. I'm not sure, but you're right. They're making it work somehow. The best managers, yes. Things that Wisconsin likes to invent. This is one invented by one of your dealers over there, which is interesting.
Well, that's I know that's one thing I've learned through the years. There's lots of very, very clever people out there, and they're trying,
Right.
all kinds of things, dairy producers and their consultants and the equipment people. I mean, it's a constant innovation.
It
And
is.
you got to give credit to people who are willing to take a risk and try something, and that's kind of the ultimate acid test of whether or not it's going to work. And
Right, right.
there's risk
Wisconsin has,
involved in it.
yes, even like the dealer in Wisconsin that has, the angled toll
Yeah.
booth, that came from Wisconsin too, and seems to be working well for those farms. So yeah, innovation, I guess. Yep. They need to keep an eye on these things, right? There's not a lot of research. Unfortunately, it's really hard to do research on this, but we just observations. Yeah.
Well, that's why being an extension specialist is the greatest job in the world because
We
you
don't need the
never
research.
you never have to sit around and think about a research question. All you have to do is walk out the door and go onto a farm. And it's like, wow,
I know.
wow, look at all that's going on out here. And there's just questions sort of pouring out. So it's
Yes.
a fascinating ride in that respect.
Yep.
People don't just learn from us, we learn a ton from other people.
Yeah.
Yes, we do, and especially from the farmers. It's amazing what they come up with.
Yes. Okay, as we get towards the end here, I'm going to have kind of a closing question for you all to answer. And it's focused on that really high achieving robot herds that you have visited, talked to, learned from. What is one thing that you see those herds are doing that you think is really helping them be that really successful herd, that other farms could, implement that on their farm to help them out?
So I can go first. So commitment to management. Since, as Doug explained at the very beginning, so the initial idea is this robots will reduce the labor needs, right? But by time we learn that labor needs change, and it's kind of we have to adapt that one. So commitment to management, from my standpoint, from my research standpoint, good ventilation design. I will say those two.
Kind of impossible, one thing, but I agree with her. The management, transition cow programs are really good. Um, Focusing on forage quality and good quality forage, and the whole feeding, how you manage that, and the combination of feeding table, the feed tables, milk mission settings has to be really done right. There's just one, it's hard to say, Caitlin, one thing, because it's really a very interdependent system, and you need to do everything right, and you need to do even better than a conventional system because a lot of parts going on here. So focus on management, but management of everything, of the cows, pre-fresh, post-fresh, training, feeding. I mean, it's a lot of things, Caitlin, cannot narrow down to one thing. If you just do one thing, you're not going to be successful. You have to do a lot of things right. And it comes to the holistic approach. So farmers that have a very holistic approach and look at all the different aspects of this are the ones that are successful. It's been my experience.
Well, I'm just reflecting on way back in ancient times when we were monitoring. Uh, my lab we monitored all the robot farms in the U.S. for a period of 3 years. So we'd watch them, before robots, after robots, looking at all sorts of things, right? And one of the things that popped out of that study is that, like, for example, um, milk production, per cow didn't change much. Uh, uh, Somatic cell count didn't change much. So farms that were good at producing milk before robots were really good at producing milk after robots. And farms that were good at mastitis management and animal health care before robots were still really good at that after robots. So I think, to kind of underscore what Marcia and Nesli said is, this is a technology because of the capital cost and the economic risk associated with that. It's a technology for superior management. You have to already understand how to get milk out of cows and how to keep cows healthy and how to, keep cows, your repro system. So I think, and just from my lens, from a milking management standpoint, high producing cows with no mastitis are a lot easier to milk. It's just a lot easier to manage a herd of really high producing cows and low, mastitis rates. So, it just makes, it's just really the fundamentals, I guess. You gotta understand cows, you gotta understand nutrition, you gotta understand animal health, you gotta understand all
Yep.
that.
It's not for everyone. You have to be that really good manager. Good point, though. Yes.
And it perpetually amazes me to be a successful dairy operator, how many things you have to be good at. I
Exactly.
think that really makes that job unique, right? I'm
Very.
a little professor here, and it's like I'm good at one thing, but a dairy farmer like has to be good at 20 things.
It's really huge system. Yep.
Yeah.
Very, very complex. Yep.
Yeah, there's a lot of things we've learned today. I think just in general, we know there's a lot of things that go into managing AMS. And a question that came in that I can answer real quick right now is where do I go for more information about managing AMS? Well, the great thing is Extension. Both us and University of Minnesota has some great Extension resources as well about managing AMS herds and starting in those basics and what does that look like? So if you're looking for some more information, you can go ahead and check out those websites. I would love to thank our panelists that we had today. It was a great conversation. I appreciate you guys taking the time out of your day to join us. And I will quickly give a preview of what our webinar for next month will be. So if you enjoyed this conversation, we have another panel that will be happening next month. The date will be November 18th, and the title is Hey There, Let's Talk Feed Centers and Inventory. So myself and my colleague Jackie McCarville will be introducing a inventory spreadsheet tool that people can access on our website. But then we'll also have a panel joining us of Grant Grinstead of Verclair Farms, Jake Peisig of JTP Farms, and Ryan Schultz of the Pagel Family Businesses. And they're going to be sharing in how they have designed and fine-tuned their feed centers for efficiency and performance. So if you'd like to attend that, we encourage you to join us. You can register on our website if you haven't already. The link is the center link here on the screen. And then if you're looking for more information, such as those AMS resources, you can find those on our dairy website, which is this first link. As well, you can check us out on Facebook, and this webinar will be recorded and posted on our website in about a week or two. And with that, I'm going to close our panel for today. We appreciate all of our attendees and our panelists. It was a great time. Thank you, everybody.
Thank you for having me.
Thank you for having us. All right. Bye-bye.